Hello, everyone. My name is Boyana. I work for Syntella Solutions, but I also manage the events for ABD Society. For those who don't know, ABD is a nonprofit here based in Charlotte, with mission to establish Charlotte as a national analytics and big data society. Thanks to UNCC, we are hosting these events monthly, and our next event is February 27th. But just the weekend before, on 21st and 22nd, we are hosting our biggest event of the year, the Queen City Hackathon at Red Ventures. So don't forget to register about that. And I'm moving on to our speaker for today, Joe Pukla.
Pukla, yes.
Pukla, yeah. He is a chief data scientist at Midtown Consulting Group. Throughout his career, he has played leadership roles across in telecommunications, financial services, and logistic industries. Today, his primary focus is to help his clients leverage data assets and analytics to gain competitive advantage and optimize options. So I will hand it over
All
to
right.
John.
Thank you so much. All right, everybody. Good afternoon. First, thank you all for taking time to come out today and be with us here. Hopefully, you'll find this discussion, if not super entertaining, at least mostly informative. And thanks to the ABD Society for allowing me to present today. Since you've all had to sign up for this, you saw the sort of the blurb or the synopsis of what I plan to talk about today, and I apologize for the hyperbole. Changing the world, that's a little bit, I guess, sort of out there, but what I want to do is talk with you today about what I'm seeing and what our clients are seeing in terms of trends in certain technologies that are really set to change the landscape of business and ultimately, I believe, society as a whole. So even though it sounds a little bit out there, I do think that what we're going to talk about today does have the potential to really fundamentally change the way we look at the world, how we interact with people as individuals, as societies, as cultures. And I describe this as sort of being inside the event horizon. I guess I owe that to Ray Kurzweil to a degree with this whole singularity concept about things converging. And the point I really want to make about this is that when you're inside an event horizon, if anybody here studied physics and understand black holes to a degree, you'll know that relativity says that as you approach a black hole, when you cross the event horizon, you don't necessarily notice anything's different. Everyone outside, anyone who's outside the system can see that you've crossed the event horizon. Now you're inside the influence of the black hole, but you yourself don't even realize that you've crossed that boundary, assuming you survive, right? But you wouldn't physically notice any difference. And I think that that's a common pattern throughout history when you look at events or series of events that really have fundamentally impacted human culture, human economics. It's not always apparent in the moment that that change is occurring or has occurred, but after the fact we can look back and see that indeed those things that may have looked unconnected or disconnected have joined together to create something entirely new. So just to kind of set the background for that conversation and thinking about what convergence means and about this idea about different things that are unrelated coming together and driving substantial change, I thought a good example of that would be the Industrial Revolution. And I know that we all know what that is, but just sort of humor me for a moment and let's think about the world sort of from the beginning of how we measure the calendar today, starting in 0 AD. Through the 1800s, you'll notice that for the first 1,000 years or so during this period, GDP as a measure, and this is in I think $2,000 US dollars, was relatively flat for a very long time. And that's because basically the way economics was driven during that time was driven by a single factor, and that's population growth. So if there was a population explosion, overall GDP went down because it was constant relative to population. When something like the plague came along and population decreased significantly, you would see an increase, but it was relatively modest until around 1000 AD, give or take, between 1000 and 1500. The agricultural revolution really began to take off, and that's when farmers learned how to use technology at the time to improve their productivity in farming the land. It was primarily through using machinery like seed drills to be able to plant seeds consistently and constantly in a straight line, using machines to harvest. It really began to improve the productivity of farms, and that in turn increased the per capita output. So up until about 1800, that's the effect you saw. Improvements in agriculture improved the ability for society, for countries and populations to produce produce, and therefore increase GDP and overall earning potential for people. Then if we look at the period from around really 1800 to now, something significant happened, right? And this is what we refer to as the Industrial Revolution. There was a significant spike in productivity per person across Western Europe and then into the US and Eastern Europe over time, and Japan as well. And there are a number of factors that led to that, but something happened. Something changed relatively quickly and radically that increased the standard of living for people in those areas, essentially overnight, and then throughout, and still continuing today. And what were those factors, you may ask? There were a few things that led to this. In hindsight, at the time, it probably wasn't terribly obvious what was going on in the whole, but the first thing was this concept of a capitalist economy, or laissez-faire economy. Adam Smith and his Wealth of Nations sort of paper was the beginnings of modern economics in terms of the concept. But it also embodied the thinking at the time, moving from mercantilism, which was controlled essentially by just a few wealthy monarchs across the world, to an economy that was driven largely by market forces, the invisible hand as it was called back then. It really began to put the power of choices on where to invest money and how to address markets in the hands of the people who are actually running those enterprises, farms, the new concept of factories, things like that. It was really beginning to change the way people were thinking about how economies worked and how to make decisions about where to invest money and who could invest. It really pushed it down into more of the common individual. The second major change, and this one we can argue whether it was a good thing or a bad thing, but it certainly had a major impact on the Industrial Revolution, and that is imperialism. So many countries in Western Europe, the UK, Spain, France, Holland, the Netherlands, a number of countries were beginning to exert their influence across the globe. They were forming colonies in Africa, in the New World. They were bringing their principles of capitalism with them along the way, and they were in turn funneling huge resources from those colonies back into their domestic output. So they were essentially fueling their own economies through the resources of the geographies that they were colonizing. So there were plenty of bad things that went along with it, but it did pump additional resources into this burgeoning capitalistic economy that was being formed in Europe and in the U.S. The third thing is coal mining in particular, mining in general, but coal mining in particular. And in the UK in the late 1700s, early 1800s, organized mining began. The UK had a huge abundance of coal as a natural resource, and they learned how to mine it effectively in mass. And that, of course, fueled the furnaces of the factories that were being built in the UK, and then similarly across Europe and the US. So having an organized supply, constant supply of energy to feed the factories was another major factor. And then lastly, this continuation of the agricultural revolution. People were able to leave the farms, right? So whereas typically a farmer's family, all their children would be involved in some aspects of farming, with the innovations that had been occurring with machinery and with farming techniques, they needed fewer hands on the farm to make the enterprise work. And so children were able to leave the farms, move to the cities, work in the factories, and it just created this cycle of increasing, this positive feedback loop, if you will, that continued to push the Industrial Revolution. And in fact, if you look at today-ish, this is as of 2002, in 1900 alone in the U.S., we've seen a 14-fold increase in GDP, or individual productivity, in this country. 14 times in 100 years. growth. It's just a phenomenal increase, and some of it was fueled by the sort of military-industrial complex that was created back in World War II. But regardless, it's all been this function of increasing productivity over time. So looking back, it's very easy to see, not a whole lot happened until around the 1800s, and then all of a sudden, boom, we hit this hockey stick, right? We just hit this incredible exponential growth in productivity and earning per person in the Western world, and now we're beginning to see that lift across the world as well. But at the time, it wasn't necessarily that obvious. So just trying to reinforce that point that you don't always know that you're living in a time of rapid change until after you've sort of gone through it and you can look back. There are obviously some more recent examples. The World Wide Web is a great example. It didn't exist until 1989 when Tim Berners-Lee created this concept of a hyperlinked internet web when he was at CERN. That was combining technologies that have been around for a long time. Hypertext had been around for a while as a concept. The internet had been around since the 40s and 50s, thanks to DARPA. So there were concepts that had been around for a long time, but they weren't necessarily conceptually connected until Tim, created this idea of the World Wide Web. Think about a more recent example today with smartphone technology and smart devices. Think about everything that's embedded in your phone today that used to be either non-existent or at least separate. GPS, right? I think everybody probably, well, my age, had a Garmin at one point in their car, and you had to buy the CD-ROM every year for $80 to update the maps, and now you get that in milliseconds on your phone. Smart watches integrating, the functions of a watch with a telephone, with calendaring, with messaging, all that. You see that convergence and getting smaller and more personal every year. And then maybe more relevant to this group, you think about the convergence we've seen in the data world, right, with the technologies and techniques we have with managing huge volumes of very complex data, the ability to do rapid and multiple types of modeling on that data to look for trends and make predictions, and then being able to visualize that information in ways that make it easy for non-data geeks like us to consume. It's just incredible the examples that we're seeing today of convergence in different areas. And I think that in addition to these, we're on the verge of another convergence of technology, one that's going to have, I think, a far more fundamental impact than these have had on our lives, both personally and as a global economy. By the way, in terms of the World Wide Web, if you want, the original website, this is the very first website that Tim Berners-Lee and his group ever created. It's still out there. CERN refurbished it a few years ago and put it out on their website. So if you want to go and see what the web used to look like as a single web page with some children hanging off, that's it. That's there. So let's talk about what I'm seeing and what my clients are seeing today in terms of technologies that are evolving and beginning to come together in really interesting ways. And these should come as no surprise for this group. But the first one's artificial intelligence. And that's sort of a loaded concept. I'll talk a little bit about the history of AI in a minute. But this whole concept of being able to use the amazing and cheap computing power that we have today to be able to use that technology to make decisions, to be able to identify trends that are not immediately obvious even to humans. We can do some really amazing things with these. If you look at it, they're really not that complex, these networks that we can build. They can do these really amazing things. Now we can debate, and I have debated the term intelligence applied to this concept. I'm not sure that intelligence is the right word to use for neural networks and for expert systems, but it's certainly, at least maybe in a savant sort of way, an incredible thing that we can do today with these networks. And like I said, we'll talk a little bit more about them. The next one is blockchain, and this one you really can't really bring up the web page without seeing blockchain in the news or in trade publications. It's such an overhyped concept right now for a number of different reasons. But there's something really interesting about blockchain as a concept that we're beginning to see gain traction across a variety of industries. If you don't know what blockchain is, just at a really high level, it's essentially a ledger system. It allows you to verify ownership of information or money, cryptocurrency. cryptocurrencies. You guys all know Bitcoin. But it creates a method for validating and verifying ownership of that information or that asset in a peer-to-peer network or a peered network, both either open or closed. You can have closed peered networks. But it allows you to validate ownership, and it allows you to transfer ownership in a secure way. And it allows you to go back in time and verify that chain of custody or that chain of ownership since the beginning of time for that blockchain. So the importance here is that being able to create a trusted set of information in an untrusted environment. So think about the internet. I can't think of a more untrusted environment than the internet. So how do you guarantee that the Bitcoins or the Ethereum coins that you have, the Ripples, are yours? This concept of the blockchain allows that to happen relatively quickly and in a way that is relatively unassailable, not entirely, but relatively. But that's an important concept in terms of being able to link together networks of different entities or concerned individuals in a way that's secure and that everyone can agree on the outcomes of any transaction that occurs on that network. And then lastly, the Internet of Things. Again, another fairly hyped concept these days. But, I mean, you all know every device that you have, anything that's got a battery today, almost certainly has an IP address, almost certainly is connected to the Internet in some way, shape, or form. Maybe it's a private net, your home network without any connectivity to the outside, but it probably is connected to the outside. But everything, and I mean almost everything today that is a device has a connection to the Internet and is a thing on the Internet. So it almost becomes, if you will, the skin, of the Internet. It's the sensor network. Some of it subconscious or completely, unconscious. Some of it more conscious in terms of awareness by other devices. But it becomes this nervous system, if you will, for the Internet in a way. And we can talk more about that as well. But these are the three that I want to talk about today. These are the three technologies. And hype aside, understand that there's a lot of noise around all these things right now. But these are three technologies that are achieving scale, they're producing results, and there are obvious connections and implications among the three that really are driving them together. And I think we're going to see some pretty phenomenal things in the next few years from these. And by the way, ask questions along the way. I know we have time set up after this discussion for questions, but I'm happy to field questions. This is a very cozy group, so I don't mind pausing. So let's talk a little bit more about artificial intelligence. And you may know this, so bear with me if you do, but I think it's fascinating to think about where we've come from where we began with this concept of artificial intelligence. It actually began a while ago. I don't know if you're familiar with McCulloch and his partner, Mr. Pitts. They, in I want to say 1949, published a paper, I think I have it up, called The Logical Calculus of the Ideas Immanent, spelling, different than it is today, immanent in nervous activities. So these professors came up with this concept in the late 40s of how the human brain works from a neuronal standpoint. From an individual neuron standpoint. How does a neuron function? What computation does a neuron perform that then creates this kind of idea of a memory or ability to act on stimulus? And so the paper is it's pretty involved. It's very mathematical. It relies a lot on set theory and the language of set theory at the time. So if you're into that kind of stuff, it's a good read. I'm a number theory guy myself, so I loved it. It's fun to see how scientists at the time thought about how our brains work. So anyway, so there's that, and they sort of fueled this initial research and investigation of how we could use this concept of a human neuron turned into a computation in the real world. And there were a couple of things that came along in the 50s and 60s. And I think I have the order right. The first thing was a network. It was a very simple neural network called Adelin. It was created by a couple of professors, I think a professor and his grad student actually at Stanford University. And what they were trying to do was to build a feedback mechanism to eliminate echo on telephone lines. And so they created this fairly simple network of, I think there were 2 or 3 input nodes, and then a fairly thin layer of nodes in the middle that would do this computation that would damp. So echo is an oscillation, right? So when you get an echo, it's a reverberation off the surface. In telephony, it's reverberation off the endpoint of the phone line, and you get the echo in the earpiece. They created a network that would damp down that oscillation. So instead of perpetuating it, it would damp it down. So you just get the initial signal, and then it would flatten out. They used a simple neural network to do that. So Adelin was the first. That was sort of the single layer, and then they came up with Madelin, which is many Adelins, that made it even better. In the late 1950s, Minsky and company came up with this idea of the perceptron, and that was the first sort of mathematical articulation of what became the modern neuron and neural nets. But again, it's a simple set of inputs into a common function that basically evaluated those inputs and then produced an output. Think of it as maybe a light photoreceptor in your eye reacting to a photon when it hits and then producing a signal in your brain. This was the idea, is to model that simple single neuron and its response to a stimulus. These were super simple. Not surprisingly, computational power back in those days was pretty minimal, running on vacuum tubes. This was the days of the UNIVACs, if you've heard of UNIVAC, when computers filled an entire room, and the computer that filled this room would be less powerful than this watch today. So pretty amazing they were able to even do this at all, and they were able to get some pretty interesting results. Moving into the 70s and 80s, there was significant work continuing. I won't go into the boring details between the 60s and the sort of the 80s. This guy named von Neumann, which you may have heard of, a relatively famous scientist, basically said, don't even mess with neural networks. They're too complicated. We can't run them in current computing environments. It's not worth it. And he was right. With vacuum tubes, really, this is about the best you could do. But even so, in the 70s and 80s, scientists like Hopfield, and I don't remember who came up with that application, it's escaping me, but there was work continuing in the concept, in the field of neural networks. These were pretty simple networks. They could do things like solve the multiple traveling salesman problem. If you've heard of that, if you've got 20 cities and one salesman, and he wants to visit each city only once, what's the optimal path to follow? Right? I mean, that was pretty important back in the day for people, computing their gas mileage and expenses. So the Hopfield network would come up with an optimal solution for that problem, which was pretty awesome. It's pretty neat that it could do that. There was another problem called the multiple traveling salesman problem, which I worked on back in the 80s. And that's, let's say you have 3 salesmen in 20 cities. What's the optimal path for each city to be visited by once by only one salesperson? That one doesn't have an optimal solution, but there are suboptimals you can come up with. It's really good, by the way, for targeting missiles when they're flying in mirrors, targeting. Anyway, so that's what I was working on back in the 80s. And then this concept of back propagation. So early on, training neural networks was sort of a hit or miss kind of deal. You could train it based on what the inputs were giving you. You could train them based on what the outputs were showing you. But there was no good way to really kind of minimize the errors that were coming out of these things. Somebody whose name I have written down, but I can't remember, came up with this idea of feeding the errors back to the system in a backward way, back propagation through the network to reduce the errors. And essentially what you're trying to do is find the minimus, or at least one minimum, in the solution space. And so that really significantly improved the ability to train networks, and it's still something we use today to train neural networks, this concept of back propagation, propagating the errors backward to try to reduce them. These were, modestly more complicated. The networks I worked on back in the 80s were 3 to 4 layers deep at most. The Hopfield networks that we trained for the traveling salesman problem took about 12 hours to train, and then to run, so 12 hours training and running, and they produced pretty lousy results, but it was pretty awesome at the time because nobody was able to do it before then. And then we just begun sort of image processing back then. We would take an 8x8 binary image of a pair of scissors, and we'd rotate it 10 degrees, and the computer would say it's a pair of scissors or it's not a pair of scissors. It's like the internet meme, hot dog, not a hot dog, or pizza, not a pizza, whatever it is. We could do that, rotating by 10 degrees. If it was more than 10, we couldn't do it, but 10 degrees we did. And then things went quiet again for a while. Between the 80s and the 2000s, not a lot happened. Computing power didn't really, it certainly grew exponentially like it has, but the application to neural networks was sort of stuck in this mode of simple networks, simple training mechanisms, until early 2000, when this concept of it's called a deep Boltzmann machine. I won't go into boring details, but research organizations, driven in large part, honestly, by companies like Google and eventually Amazon, were driving into this idea of how do we increase the ability for systems to predict nonlinear situations. So you know all the linear regression, right? You have a bunch of data points to draw a line, best fit, least squares, right? That's how you create your linear regression. What happens if the data space is nonlinear, right? So you've got maybe a cluster, and there are clustering techniques you can use, K-clusters and what have you. But what if you want to be able to do it quickly on data you don't fully understand? Well, this idea of a deep Boltzmann machine would allow you to basically develop a nonlinear kernel or a training algorithm that would allow you to create these sort of pockets of predictability and commonality. And so that really drove a lot of additional interest in the 2000s, which then led us to this sort of explosion of different network models, from LSTM models for sort of predicting temporal events to GANs for determining whether a deepfake is a deepfake or not, to if you're familiar with YOLO for image detection, right? I mean, all these different algorithms that came out, and they were all combinations of, and this is small, I apologize, but inputs and sort of hidden layers, which is where all the magic happens, and then the output layers. And I mean, to this day, our understanding of how these things work and which networks to use for which problem, how to set those networks up initially so that they perform well at the end, hyperparameters, if you guys have done any study of neural networks. It's all still a little bit of magic, but we've been able to drive some really, really incredible results with that magic. And I always fall back to the idea, of self-driving cars and Tesla. Even, and honestly, guys, even 10 years ago, if you'd said that a car could drive itself today, I don't know that a whole lot of people would have bought it, but they do. And I know there's a lot of controversy with self-driving cars now and their ability to make decisions in situations where lives are at stake, and that's certainly true. But the fact that they can even stay on the road, right, and understand what a stop sign is and a stoplight, and they can see other cars and know how to avoid. It's incredible what we've been able to do just in the last really 10 years on that front. And it really extends beyond self-driving. Image detection has just exploded in terms of being able to support security applications for facial recognition. I spent a lot of time in China. I'm not sick. Again, good or bad, they use facial recognition. The city I go to the most is Shenzhen. Shenzhen has the most cameras of any city in the world. They have systems produced by Alibaba that can detect a single face out of 200,000 in one image. They can identify a person. And so and that's all neural networks. It's just phenomenal how much progress has been made in just the last few years. But again, how do we measure intelligence? What does it mean to be intelligent? And I don't know. Is it image detection? Well, that's one form I would say of call it smart, I guess. Natural language processing, and what is it, GTP2? I forget. OpenAI, what the natural language processing algorithm they released recently, which they said was the most dangerous neural network in the world, right? Because it could totally pass the Turing test. Playing Go and creaming humans, and the same with Jeopardy. Are these forms of intelligence? I guess, depending on how you measure it, but it's the same thing with measuring intelligence in humans. How do you measure intelligence? IQ, okay. What about musical quotient, emotional quotient? I mean, all these different ways to measure intelligence. It really depends on what you're talking about. So I think in deep linear slices, vertical slices, yes, we can talk about intelligence, but I don't know that we figured out a way to kind of cohesively integrate all these things into a unified intelligence for machines and machine learning. But anyway, that's a topic for another conversation. Moving on now to blockchain. So blockchain in its initial instantiation, it was Bitcoin, right, in 2009 when whoever Satoshi Nakamoto is, whoever he is, came up with this idea of Bitcoin. In that instantiation, all it really was a ledger that allowed people to record transactions and to verify those transactions occurred as they were supposed to. Which is great. It's fine. It's not that exciting, to be perfectly honest. And there's lots of opportunity for bad behaviors, because it's somewhat anonymous, not really, but sort of is. It makes people think it's anonymous, which makes them do stupid things. But the real benefit to blockchain that we're seeing now is this concept of smart contracts or smart ledgers. And that's when you embed not only data in the blockchain, but event logic. So think about selling a house, okay? So I put my house in the market. What happens today? I get a broker. They help me get the house ready for sale. They bring people in to view it, or the buyer's agent does. We agree on a price eventually through negotiation. They come in with an inspection. They look at all the things they think are wrong. We agree on what I'm going to fix versus not. There may be some changes in pricing based on that. And then we get to the final signing of the contract, and it's 2 hours worth of paperwork to get it done. And maybe there's a problem along the way, and it's longer, and you have to go back. So it's just a pain in the butt, right? What if you could bake all that logic into a computer algorithm and allow the process to manage itself? Now, there's still human involvement. I still have to get my house ready for sale. I still have to be involved in the decision about what I'm going to price it as and what I'm going to accept as an offer. But all the other stuff, right? Responding to the inspection requests, negotiating details, I can bake a lot of that into an algorithm or into a set of algorithms or decision trees that really pulls me out of the process. And the final contract signing, do I really need to sign 50 different documents to sell a house? Right now, yes, but I mean, you could certainly automate that process if you understood all the different pieces and you knew the decision tree on, okay, well, so this information is not correct. Okay, we have to go back and re-enter the information and do it again. All that can be automated. And so that concept can be applied to pretty much any business process that's well understood, right? Not every business process. Some are just too complex to sort of fall into this mode, but there are plenty of business processes that could be managed in a much more automated fashion. We've talked for years about business process management, business process automation. This is sort of like the next gen of business process automation, because you can really kind of join it together in a way that can be supervised through governance and conducted over networks that are trusted based on the way they're architected. And I won't go into a whole lot more detail about open and closed networks, but there are other things you can do to make it even more secure and more trustworthy. But this is another concept that we're seeing. And again, there's a lot of hype, there's a lot of failure. The real estate example I mentioned, if you go to look at Vermont and what they've done in Vermont, they passed legislation 2 years ago to allow for more technology in real estate transactions. And so a company called Plotly, no, not Plotly. I don't remember. I'm sorry, I can get it for you guys. There's a company who released a blockchain platform that allows for D-transfers through blockchain. And they've done one. In 2 years, they've done one for one principality. They're trying to get a lot of positive press to make it available in more principalities throughout Vermont and then eventually the rest of the country. The problem we're seeing with that particular instance is it's sort of a bottom-up approach, grassroots approach, and so you have to go to every single locality and get them to approve this as a process for transferring deeds versus some things that can be more top-down, which is where we're seeing more applicability for blockchain across business. When, as an example, Ripple, that's another great example in the financial services industry. Ripple dictates that their network is closed. They manage all the financial transactions that occur over that network. They manage all the coins that are associated with that network. And they essentially can, any participant, and by the way, Ripple's used for foreign exchange, for large cash transfers between financial institutions. They can dictate how that all flows, and it's getting much more buy-in in the financial services space because of that. And then, okay, so the last one, Internet of Things. So I think, we've talked conceptually about what this is. I think that the thing to note is that this is not in any way, shape, or form a new concept either. Since the Internet's existed, there have been devices with IP addresses, therefore there have been Internets of Things for a long time. What's new is how we're talking about how those things interact. If you recall back in the 90s, early 2000s, this concept of intelligent agents, everybody was going to have a personal assistant that lived somewhere in the network or maybe on their phone, their Dick Tracy phones, that would manage their lives. It would book travel, it would schedule meetings, all these different things. Didn't quite get there, hasn't gotten there yet. It's still floating around out there. But what has gotten there is this idea of connectivity, right? So your Ring doorbell, right? You can hop on your phone right now and see who's at your door. You can look at the footage from your house on your camera. Make sure your cats aren't tearing up the house. All these different things you can do with devices that are connected now. Really just scraping the top of the iceberg on this, guys. I mean, having things connected is one thing, and that's great. Being able to have simple interactions like looking at your doorbell camera is another. But think about being able to, let's say you're Maersk, right? And you've got shipping containers all over the world. Wouldn't it be great to know where they are? Wouldn't it be great to know what's inside of them, because they should have their own RFID tags or whatever would connect them to the internet? Wouldn't it be great to be able to say 2 weeks out where those containers are going to be, so you can optimize your container flow and your shipment flow across your global footprint? Those are the kinds of things that we're beginning to see in idea stage. Those are the kinds of things that are going to become, I think, fundamental game changers in business and eventually personally too. I think this idea of a personal assistant, this idea of an intelligent agent, will get there. But I think some more work's going to need to be done at the personal level for that to really become a thing. But I do think it will become a thing. And just to drive the point home a little bit more deeply, if you look at your car, if you bought a car within the last 3 or 4 years, this is your car. And each one of these little dots is a sensor or a device that is measuring some aspect of your car's performance. Tire pressure, oil levels, rainfall, all these different things. They're all being measured, and by the way, they're all being recorded on the computer or computers in your car. And by the way, a lot of the information goes back to your manufacturer without you knowing about it. Because they have devices that are connected to the mobile networks that feed telemetry back to the manufacturer, so they can improve their manufacturing process, improve the products that they provide to you on the automobile platform, and to come up with new ideas for new products that would make it even better. So your car is an Internet of Things on its own. Just thought I'd let you know that. Big Brother's watching. All right, so what's happening today as examples? And I won't go into detail on these because we're getting close to time here, but I'll just say that if you look at AI and blockchain, there are some examples of things like DeepBrain, which is distributed AI through blockchain, or Numerai or NumeraI, however you want to pronounce it, which is sort of this competitive, it's a bizarre thing. It's a hedge fund that uses competitive data science projects to drive the hedge fund. You guys, if you figure it out, you let me know. I don't get it, but it's pretty cool. I thought I'd mention it here. On the blockchain and IoT side, there are a number of things. HDAC is Hyundai's IoT company. Streamers partnered with automakers and other companies to essentially manage IoT devices and sort of their disposition or their status through blockchain. IOTA is another sort of prominent one that gets a lot of press. And then on the IoT and AI side, obviously Tesla for self-driving cars. I mentioned Alibaba. They have this concept. I love translating Mandarin to English. City Brain, right? Smart city. But City Brain is what they call it in English. This idea of having connectivity across energy, transportation, emergency response, government agencies, right? All the business licensing, all that integrated into one platform. So we're seeing them come together in bits and pieces. But what I'm proposing is that very soon we're going to see all three of these things really begin to come together as a unified platform. So we talk about unified communications today, where you can have you can do a WebEx call on your mobile phone and transfer it to your desk, and then transfer it to your home phone. All these different concepts of things integrating together seamlessly. We're seeing a convergence of these technologies together in really interesting and neat ways. One example, if we look at healthcare, and each one of these things is a separate sort of use case or business case. Each one of these things we're seeing kind of happening on their own, but we are beginning to see thoughts of how we join all this together. So as a patient, being able to go to your doctor, the doctor collects data for you, and I think the errors probably wrong here, but they share information back onto the network. You can pay with crypto. Let's say you need to go in for a CAT scan or MRI scan. That information could flow through to the radiologist. An AI could be used to interpret the MRI data and detect, I don't know, a torn meniscus that's minute or cancer or whatever. All that information then gets fed to, or maybe you get lab results done too, and all that gets fed into here. The results fed back to your doctor, and then prescription to the pharmacy. And all this data, genericized or depersonalized, can be fed into researchers to do to influence their clinical research, which is pretty cool. And all this can be managed, like I said, sort of simply by, call it an AI, call it, just a central sort of watcher to see how this is all flowing together, because the doctor may notice things that the radiologist didn't catch, or vice versa. Same with the lab technician. The doctor tends to be the focal point today for all these different things, but if there were a second set of eyes, if you will, looking at all this together with the doctor, it just improves the viability of the whole model significantly. So this is just sort of an example of how it might come together. Blockchain would be used to sort of share all this information across parties in a secure fashion. You'd be able to see who accessed it when and what they did with it as part of the blockchain. So, and your identity could be managed on the chain as well. So all that together. Take it to the extreme, and you may have heard this concept of radical decentralization. It's something that's kind of flying around now on the interwebs as a meme, but it really is a thing. If you think about being able to stand up services that are managed locally, right? So local power generation, local services for EMS and what have you, education, and healthcare, all controlled and managed locally. But let's say that there's a disruption to service. Let's say there's a tornado that comes through and it takes to the hospital. Unfortunately, by integrating data from city to city, you can immediately, without having to even make a phone call, cities around you can be notified to expect additional traffic into their hospitals or healthcare facilities because of that. Emergency response units from those municipalities could be deployed to that location, including other emergency responders like police and what have you. On the energy grid, we already have a fairly rudimentary network in the U.S. anyway, and I guess North America for power generation and distribution, but it's really, really lousy. I mean, you guys know about the brownouts that we've had, and the last big one, I guess it was like 8 years ago, but the system hasn't evolved that much since then. If a transformer goes down in the wrong place at the wrong time, it takes down half or maybe all the network for a while, because the way they load balance the network is through the electricity, and when you cut out part of the electricity in one area, it can trip a whole bunch of breakers across the rest of the network. So ideally, you would have a network that is self-healing for power as well. And so when, let's say that the hydroelectric dam gets taken out for some reason, instead of creating a brownout in that area and potentially impacting a much broader area, the system would be able to anticipate the problem and isolate it immediately before anything else was damaged from a power generation standpoint. But you can see that concept sort of growing from grassroots to the world eventually, in terms of connectivity, and that's at least conceptually where we see things headed. So what does it mean for us, right? Quite simply, guys, and this is why it's relevant now. Everything that I just talked about relies on data in one way, shape, or form. I mean, frankly, everything we do today relies on data in one way, shape, or form. But for AI and blockchain and Internet of Things, it's all connected through data. And so for us, it really becomes, how do we help enable the capabilities that are going to be, sort of possible with these technologies? And I'm sure these are things that you guys either know or have heard or get a lot of attention today, but it's true. If you think about it from the standpoint of sort of building stuff and modeling, you can't get away. I mean, granted, C, C++ is still big, but really in today's world, it's Java and Scala for performance. Python's a great tool, and R for modeling. In terms of AI, the Python platform, again, tends to be the one that's most popular right now and generating some of the best results with PyTorch and Keras and others. Deep learning for Java is great. It also runs in Scala. On the blockchain side, there are a few that are really getting a lot of attention for being rock solid. Ethereum is one of the most well-respected networks out there for open blockchains. They had some issues a few years ago with their blockchain being hacked, but they created a fork and it's better now. Hyperledger is another great one, and Hedera is a relatively new one, but that's really more sort of a distributed, sort of focused on Internet of Things network, which has some promise and interest. And there are others, but those are some of the big ones. For Internet of Things, you're really talking cloud computing at this point for IoT. So any of the current popular cloud platforms are worth knowing and investing in. And then on the deep data side, of course, is what we use every day, right, guys? I mean, it's knowing you got to know SQL. Can't get away from it. And then the big data tools, Hadoop and Spark. I think the point to take away here is that there are no surprises and nothing's going to change. These are the tools that will build whatever that amalgam, that connected intelligence becomes. These tools will be responsible for building that future. So these are good things to know. And you don't have to know them all. It's great to specialize in a layer or in a slice. So just to end on a note, I'll say, Ray Kurzweil, again, just to return sort of to him and this whole thing, from his standpoint, he's been talking about this for a long time. We're only 20 years away from computers being super smart and super small and inside our bodies. So, do with that what you will. I don't propose or espouse that concept necessarily, but that's his opinion. Then again, he also said a few years ago that by 2010, computers will disappear and our clothing will have computers in them and we'll all live in VR, and that didn't happen. So take it with a grain of salt. But I'll also end on my favorite Robopocalypse quote, which is, machines will certainly soon be smarter than us and probably control the world, so get ready for it, guys. And that's all we got. Any questions? And we have 10 minutes, I guess. Yes?
So if you had to pick one industry, I know you mentioned self-driving cars, emergency response, healthcare, right?
Yeah.
If you had to pick one industry that is going to be most impacted over this coming decade by AI, what do you think it's going to look like?
Most impact is hard to say, but there are some obvious ones that will be impacted heavily. Financial services, without question, for lots of different reasons and in lots of different ways. Being able to effectively manage pools of funds and put them in the places where they earn the most money at the lowest risk. That's ideally suited for AI techniques, and those don't have to be very complex networks. And in fact, they're being used today at many of the banks, not even the larger banks. A lot of the smaller banks are adopting AI in that capacity. Shipping and logistics is another great area for AI because if you think about the complexity of getting a set of goods or a pallet of goods from one location to the next, along with a whole bunch of other unrelated pallets of goods, how do you do that in the most cost-effective and in the most rapid fashion? It's a great optimization problem for AI. And telecommunications, again, there's another area where AI is going to play a big role, just in terms of being able to manage, frankly, this is more at the network level, being able to manage traffic across the network and load balance it across different media, that sort of thing. So I think those industries tend to be technology heavy anyway. But I certainly do see real estate, especially corporate real estate. If you want to talk about real estate as an industry that's ripe for AI and some of these other things, being able to take a lot of the sort of guesswork out of managing office buildings, selling corporate properties, dealing with all the leases and the multiple sort of owners in those leases, and all that is a hugely complex problem. And I think we're going to see companies like Trimont and I'm trying to think who's big here, CBRE, adopting these technologies to help manage their properties more effectively. Yes?
You were talking about convergence the whole time. In your opinion, is that convergence like what AI technology being more advanced than we are as people?
That'll probably happen. What I'm really talking about is being able to use concepts from each of these things together in a synchronous, sort of synergistic way, right? So, and the examples I mentioned earlier, some of the companies that are doing it now, just sort of point to that direction. Pardon me, let me get back You know, if you look at AI on blockchain, we're beginning to see concepts where companies are exploring, and by the way, these are really, how do I describe this? They're startups, okay? So the concepts aren't always very well developed. Sometimes they just are a concept and not really a product. In the case of DeepBrain, they do have a platform that they built, but it hasn't been proven yet. But the idea is, can you create pockets of AI on a distributed network and link them together in a trusted way using blockchain to drive very complex decisions over, you know, distributed networks in a very secure way? That's the idea. So that's one type of convergence. Another with HStack is, can we take all this data from that picture I showed you with cars? Can we take all that data from cars and bring it together in ways that allow people who, you know, wouldn't otherwise have access to it to think of new things to do with it? Like, what if you combined, I don't know, tire performance with windshield wiper activity with engine, you know, like max RPM, I don't know, whatever it would be, right? But how do you bring all that data together in different ways and look for trends or detect anomalies, or, you know, just come up with ideas to make the driving experience better, more safe, you know, all those things. So that's what we're seeing. And the point with blockchain here is being able to share that information securely, so you know the information you're getting is accurate, it hasn't been tampered with. You can see where it came from, you know, sort of down to the car, but I don't know. But anyway, you have, you know, custody of ownership of that data, so that as you're making these analyses or performing these analyses, you know that the data, you know, is of quality and reliable. And I think the sort of self-driving cars kind of speaks for itself, right? Merging the IoT, which is all the sensors on the car, with AI to be able to have a coherent, complete picture of where that car is in space and time, in real time, right? So what I'm seeing is these sort of point examples beginning to converge on things that are much more holistically combined, and that's why I mentioned the healthcare example, where you have components of each of those things coming together in unique ways that really fundamentally change the experience as a patient, the capabilities as a doctor, better leverages outputs from radiology and lab to drive better patient diagnoses and prognoses, and then feeding that into future treatment plans, and then obviously in terms of treatment as well, right? So just this end-to-end view of healthcare that we don't have today. We have pieces of it that exist today, but this whole picture just doesn't exist, but it can with those technologies coming together in meaningful ways. Yes?
There's a lot of justified around just like fear over AI.
Yeah.
And I think part of that comes from us not being able to fully explain it to people that don't understand data science.
Sure.
Or the structures that
Yeah.
go into it.
Yeah.
What do you think are some steps that we can take to kind of make it more palatable?
Yeah, what I try to do with AI as it exists today is talk about it in very simple ways, and I really almost try to avoid AI as a term anymore because it's so loaded. You know, it means so many different things. Machine learning is better. It's not exactly what we're talking about, but it's less loaded as a term, as a concept. What AI does today is not really self-directed. Even with self-directed learning, it's not really self-directed. You put it in a situation and you say, go figure it out, but you've controlled the environment, right? So if you've seen the videos of an AI learning to walk, right, with just joints and muscles and it flopping around, and finally it's, you know, running. Okay, you know, that was unsupervised learning and it learned how to walk, but it was in a controlled environment. Same with the hide and seek. Have you seen the hide and seek video? If I get everybody's email, I'll send it out. It is an awesome video, and I forget who did the work, but they trained hunters and seekers in a virtual environment, and the techniques that the hiders came up with to hide and the seekers came up to seek, really, really pretty awesome. But again, that's in a controlled environment, so there's no real danger of that AI. The danger people see most is with Tesla and self-driving cars and Google self-driving cars. Can a computer really make a decision as to whether they're going to hit this person or that person? They're going to have to hit somebody. Who are they going to hit? How do they make that call? How do we make that call? Because we are considered individuals and we are classified as humans and therefore fall under the edicts of law and ethics, if we have to make that decision, we make the decision and we pay the consequences. But how do you make a machine pay the consequences for that decision? There's no right choice. It's a Sophie's choice. but at least we have someone that we can hold accountable for that choice, right? The computers can't. So that gets into this whole ethics of when does a computer become ethically responsible for its actions? And we're not anywhere near that yet. So that's what I try to do is sort of deflate that whole concern. The robopocalypse, I made a joke about it earlier, but the robopocalypse is a long way away. You know, I just don't think, you know, for me it's not a concern right now. And the best thing we can do is just kind of downplay it because people get wrapped around the hype, right? I mean, it's fun for media and trade magazines to, oh my God, you know, the world's going to end. We're going to be ruled by the, you know, by the AI dictators and all that stuff. But it's not. We're not anywhere near that right now. So. Yes.
Do you feel that the growth of AI is more along the lines of the growth or the timeline of us as people, or more kind of independent, where we're putting in the efforts to make it go faster and better as the days go by, and then it will just reach a point where, kind of like on your timeline scale,
Yeah.
kind of
Yep.
access.
So machines have the benefit of having teachers, right? And not in the same sense that we have teachers. We can observe the progress of the machine and its ability to learn, and we can make external adjustments to the machine's makeup, right? Essentially their DNA. I mean, it's not really DNA, but we can change the programming. We can change the network architecture. You know, we can influence the hyperparameters that sort of are set in the beginning that, and, you know, are used to eventually come up with a set of parameters that govern how the network works. We have complete and utter control over that process today. We don't fully understand it, which is part of the problem. That's why networks are so hard to train today. We don't really understand what happens when we set all the network value, or all the weight values to 0 versus to somewhere between 0 and 1. We don't understand why that makes a difference, but it does. But we can make those changes, and we can see what happens, and we can pick the best one. So we're sort of like evolution for computers in the beginning, right? But as soon as that computer understands how to change its own programming, which that's not that far away. As soon as it understands how to change its own programming, it can begin to, in very rapid time, change its own programming, right? And change its own ability to learn. So that's where you get the hypergrowth for computers. We don't have that yet, right? We're just beginning to understand how to influence our DNA in productive ways. We're just beginning to think about how we can program the human brain outside of standard learning techniques, right? Which we use today in schools. We're just beginning to sort of think about that stuff. So we're still on this sort of evolutionary. We're on an exponential as well, for sure. But our curve is sort of like that, and computers are down here, but they're gonna pass us at some point, just because they're gonna evolve more quickly than we can. Now there may come a time, and this is what Kurzweil always likes to talk about, where we begin to either we learn how to change our own evolutionary path more rapidly, and we begin to surpass machines, or we merge in some meaningful way, and the question no longer becomes important. But again, I think he talks about 2040. I mean, it's probably realistically, for anything significant, we're probably 100 years away from anything like that.
Awesome. Thanks so much.
All right,
It was
thank
good
you.
having you.